This lesson's on organized counting. As we go through and trying to figure out the number of ways that things can happen, a couple of rules we're going to keep in mind. If and is in the question, you're going to multiply. If it's an or question, like this or that, you're going to add possibilities. Tree diagrams are just going to be something we're going to use. Factorials are something we're going to use, and permutations are going to be something we're going to use. So you want to find this button and this button on your calculator. Now they might also look like x factorial, or it might be n PR, something like that. You want to find these buttons on your calculator that'll help you answer the questions. So as we're going to go through, the numbers are going to be quite large. Often they'll show up in scientific notation on your calculator. That is quite all right. Okay, so the first example is we're going to deal with passwords. Number of ways you can make a password up. Okay, so we're going to deal with 8-character passwords, and it's going to be letters only. So there's 26 letters in the alphabet, and we're going to need 8 of them. So you're going to have to have a first letter, and a second letter, and a third letter, and a fourth letter, and you'll be multiplying all these because it's and a fifth letter, and a sixth letter, and a seventh letter, and an eighth letter, and there's 26 letters available for all of them. Okay, so you multiply that out, it's going to be massive. An easier way to do it would be 26 to the exponent of 8, and again you're going to get an absolutely massive number in doing so. Capital letters and lowercase. Okay, so now I want to have capital letters and lowercase letters put together. So there'll be 52 options for each of them. Okay, you have 26 lowercase, 26 uppercase, and you're going to have 52 for the first letter, 52 for the second letter, 52 for the third letter, and all the way to the 8th letter. So you're going to put that in, and again it'll be 52 to the exponent of 8, which again will be an absolutely massive number. It will be significantly larger than the first one. If you have letters and numbers combined, and maybe we're going to let capital letters and lowercase letters, and then we're going to put in the 10 digits also, so for anywhere from 0 to 9 for each possibility. Now for each possibility, you're going to have 62 possible letters or characters going in, and if I'm going to have 8 of them, it'd be 62 to the exponent of 8, which again, put that in, massive scientific notation number would be times 10 to some exponent. Okay? Letters and there's letters, lowercase only, but I'm not going to be allowed to repeat. Okay, so lowercase letters only, so there's 26 options. So I'm going to 26 options for the first letter. Then I'm going to use that letter and it won't be available to me anymore. So I'll have 25 options for the next one. Then 24 for the third one. Each time I'm losing an option because I've used that letter. 23, 22, 21. Let's see, that's 6 letters. 20, 19. There's my 8 letters put out. Multiply them all together. Now fortunately there's an easier way of doing that instead of just multiplying them all together. Okay, you can also use the NPR button, and it'd be 26, and you hit your button, okay, and I need 8 of them. And it should give you the exact same answer. Now more about the permutations as we get into the next question here. So dealing with seating plan. Here's another type of example. I have 30 students, I want to seat in 30 different desks. How many seating plans are available? It's going to be an incredibly large number. For the first desk in the classroom, I have 30 students I can place. And then I'm going to have 29 students for the next one, and 28. And I'm working my way all the way down until I have only 2 students left and then 1 student. So I can be multiplying 30 times 29 times 28 all the way down until I'm multiplying by 2 and by 1. Now I'm using up all 30 students. Again, easier way of doing that would be 30 factorial on your calculator. 30 factorial means 30 times 29 times 28 times 27 times 26 all the way down to 2 times 1. Okay, and again it'll be quite a large number. I'm using all 30 students. Okay, that's where the factorial will get put in. Here I have 25 students and 30 desks. So I want to have some empty desks. Okay, I'm not going to be using them all up. So I want to start, I want to have 25 students, but there's 30 desks. Okay, now this is where I want to use the NPR button, just like I did before, where I was going from 26, but I didn't go all the way down to 1. I only went from 26 letters down to 19 letters available. Here, I'll be starting, but I'm going to have some empty desks, and desks I'm not going to be using. So it'll be 30 desks, and I need to put 25 students in it. 30p25. So permutations and factorials work the same way. You got a kind of countdown going on. You're starting at how many you have, and then you're losing one each time. With factorials, I'm going to go until I'm all the way down to 1, until I don't have any left. With permutations, you got some empty ones. I'm not using them all. Okay? Spelling my name. Let's say I want to spell last name Keister. Okay? And how many different ways can I arrange the last name? So there are 1, 2, 3, 4, 5, 6, 7 letters. Okay? I want to use all 7 letters. When I use a letter, I don't have it available for anymore if I'm making up different arrangements of it. So I want to have 7 factorial different ways I can arrange the name. Okay? And again, figure out what that number is. If I'm only going to use 4 letters, I'm not using them all. Okay? Again, I got the countdown going on. I have 7 letters available for the first one, and then it's going to be losing 1 each time. But I'm not going to use all letters. I'm only using 4 of them. So it'll be 7p4. Okay? Factorial, using all the letters. Permutation, not using all the letters. Take the word factor. Okay? Here I'm going to use all letters. There are 6 letters available. Okay? How many different arrangements can I have? 6 factorial. But if I'm only going to use 3 of the letters, it'd be 6p3. Now what gets interesting is if I have some repeated letters. Take factorials. There are 2 A's. Okay, and I think that all the other letters are unique. Yeah, there's 2 A's. I have 10 letters in total. Okay, so if I want to use all the letters, I want to have 10 factorial, but I have the 2 A's that are identical. Okay, and so I'm going to have to divide by 2 factorial. So when you get identical letters, you have to divide by the identical letters you have. I have 2 A's, so I have to divide by 2 factorial. Take Mississippi. Lots of repeated letters here. I have 4 S's. I have 4 I's. And then I got my 2 P's. So in total, there are 11 letters. So it'll be 11 factorial if I'm using all the letters. Divided by my 4 S's, divided by my 4 I's, and divided by my 2 P's. Okay? So if I was putting that in the calculator, I'd do 11 factorial first, and then I would hit equals, and then I would divide, and then I hit equals, and then divide again, and then divide a third time, hitting equals all the way between. Okay? Hockey team. Okay? There's 5 players. I want assigned to different positions. I want to use all 5 players. Okay? How many different ways can I assign these 5 players to 5 positions? I'm using all the players. It'll be 5 factorial. Now I have 10 players. Okay? And I want to put the 5 different positions. Now I'm not going to be using all 10 players anymore. But once I put a player there, again, they're not going to be available for a new position. So I am doing a kind of a countdown. I have 5, 4, 3. But I have 10 players available, not using them all. So it'll be 10p5. Running a race. 8 people running. How many ways can the finishing order be determined out of the 8 runners? You have first place, second place, third place, fourth place, fifth. Once a person won their spot, they can't be used again for any other positions. So for the 8 people, and again I have the countdown going, there's 8 possibilities for who finishes first, 7 possibilities for who finishes second, and so on, all the way down to 1. It'd be 8 factorial. If I'm going to just assign 3 medals, and I don't care about the other ones, gold, silver, bronze, I don't care about the other 5 people, I'm only using those 3 spots, then it'd be 8p3. Okay, that is part 1 of this lesson on organized counting. Part 2 will cover some other types of questions.